Welcome to your first flipped video. I hope that you really enjoy this process and come to figure out that this is a really great way to get some background information before class so we can spend class time doing a lot of the harder things that we're going to come across in geometry. So today we're going to talk about distance, and we're going to start pretty simple. We have this number line, just want to know the distance between A and B. So I'm just looking for this distance. So if we had all the little numbers on there, you could do something simple like counting them out. But we know the distance between -5 and 2 is 7. Before we get too far into this, I want to talk about the notation. When we have distances of segments, the length is equal. So if you notice, there's no notation above the letters, and we use an equal sign. If we're talking about the segment AB and the segment CD, we say that they're congruent. So we use the congruent symbol. It's just a minor detail, but as you are coming to realize, those minor details are very important in geometry. So the notation that we use will be important. Take a second and think which one of these is incorrect based on what I just said. The distances are equal, the segments are congruent. So a quick thing that you can do is check on all of your symbols. So a distance has to be equal, and my segments are congruent. And then check to see if the notation of the letters matches what we just said. So distance has no lines above the letters, so those are both fine. Segments do have lines above the letters, so this would be your incorrect one, because the notation of the letters indicates distance, where the notation of your symbol indicates segments. If I was talking about the distance between G and H, we have this thing called the ruler postulate that says the distance is always the absolute value of the difference. So regardless of whether I'm moving this way on the number line or whether I'm moving from the 4 to the 1, we don't say that this is a -3. That is incorrect. So this is a symbol you haven't seen in a long time, the absolute value, which basically just means that whatever problem you solve inside the absolute value symbols becomes positive. So if I said 1 minus 4, the absolute value, we know 1 minus 4 is -3, but the absolute value of that is +3. So that absolute value is referring to the difference. So because of that, we can say that the distance between 2 points is always positive, and that is on your notes to fill in. This next problem is also on your notes. This is a very common thing you could come across in real life. You're driving somewhere, you want to know how much further you have to go. Maybe you're going to stop at this rest area, but you want to know how much further it will be to San Diego. Our question says, once you get to Paloma Road, how much farther is San Diego than the rest area? So I know some of you are very visual learners. So here is Paloma Road in 5 miles. Here's the rest area in 26 miles. And here's San Diego in 286 miles. I realize this is not drawn to scale. But once I get to Paloma, the rest area is only 21 miles away. I figured that out. Doing 26 minus 5 and taking the absolute value, which is 21. I do the same process to get to the rest area, 286 minus 5, and the absolute value of that would be 281. Let's go back and reread the question. Once you to Paloma, how much farther is San Diego than the rest area? So I really want to know the difference of my two distances. So once I get to Paloma, San Diego is still 261 miles further than the rest area. Remember, if I'm writing things down, you're writing things down. So on your paper, you should have all of this information. If you don't, remember you can pause at any time. So let's talk about something a little different. If I wanted to know how far it was from Lee's house to Rita's house, I could count these little boxes. If I wanted to know how far it was from Rita's house to the mall, I could count these little boxes. But then I want to know how far it is from the mall to Lee's house. We can't count those boxes. So think about what kind of shape we just made. Think about what you know about this shape. I hope something's starting to come to mind on something that we can use. The Pythagorean theorem. As a quick review of the Pythagorean theorem, first we always have to know the sides of our triangle. So the Pythagorean theorem only works on right triangles, which means you have a right angle in the corners of your triangle. The side opposite the right angle, or across from the right angle, is your hypotenuse. So that's always going to be this one. That's also always your C in your equation. Then the other ones are called flex. You need to do a little bit of practice. You have this on your paper as well. So I always like to label my C's first. So here would be my C and here would be my C. If you've forgotten that formula, you might want to jot it down on your notes. So I have two different triangles. My C is, well, my X is in a different place on both, which means I'm going to have to solve it a little bit differently. So to set up this first one, we would have 3 squared plus 7 squared equals x squared. Set the next one, we'd have 5 squared plus x squared equals 19 squared. So because you should already know how to do this, at this point I want you to pause the video, finish working these out, and when you push play, you're going to have the answers ready for you. Okay, so your work should be similar to mine. If you happen to leave your answer in radical form, that's fine. Or if you went ahead and finished solving, that's fine too. That's just a quick review on Pythagorean theorem. So if we put this back onto a graph, we need to kind of connect this idea to what we already know and then connect it back to geometry. So on the back of your paper, you have this exact same graph and table. Let's first take a look at AB. Segment AB, remember we can always just count these lengths if they're vertical and horizontal, because we can count the boxes that it travels. AB travels 5 boxes. Endpoint 1, we're going to call that one A. It's at 4, 7. Endpoint B is at 4. My next column says the change in the x values. That's the absolute value of the change there. Well, if I look at my x values, my absolute value would be 4 minus 4. Well, that's just 0. The other one, I have 7 minus 2, which would be 5. Now It doesn't matter if you switch these because you're doing the absolute value. So for example here, if you had done 2 minus 7, you would have gotten negative 5, but the absolute value of that is still 5. The next one, KL, if we just count the distance, it just goes 3. We fill in the points for K and L. K is at -1, -7. And L is at 2, -7. We do our changes here, our little absolute values. I'm going to write down here. -1 minus 2. -1 minus 2 is -3, so the absolute value is 3. And then the other one we have -7 minus -7, so that would be to change to 0. So what do we notice here? Segment length is 5. If I combine these somehow, I get 5. My segment length is 3. If I combine these somehow, I get just 3. So that works great when I want to find horizontal and vertical distances. But I still can't quite do that if I do this. But remember we talked about that this is kind of like, or this is, the Pythagorean theorem. So this is how I'm going to introduce this next formula for you. Let's start with the Pythagorean theorem. We have that a squared plus b squared equals c squared. Well, to find this distance here, we just did the change in my x's and the change in my y's, which is that we just subtracted the 2 and subtracted the 2 y's. So if I were to do that and square both of those, then I have to take the square root to really finish solving, and I get something that looks like this. This is not as scary as it looks, promise. So the distance formula, which is kind of what this is just like the Pythagorean theorem in disguise. Something you've kind of already done, not that big of a deal. Here's the real distance formula. You can go ahead and write this in that box where it says distance formula. You have x squared, I'm sorry, not x squared. You have one of your x values minus the other one, and you square it. You have the other you have a y value minus the other one, and square it. Add that together, take the square root. Easy peasy. So we have, this is your first example. I'm going to write the whole thing out. We're going to use this as point 1, and this is point 2. So my point 2 x value is negative 3, minus my point 1 x value is 2. Square that. Plus my point 2 y value is 1, minus 8. Square that. Okay. From there, I do this subtraction, which is kind of like adding. So I have negative 5 squared. 1 minus 8 is negative 7. Got to square that. So I have 25 plus 49. Got to add those together. Which gives me 74. Finally, I take the square root of that. I get about 8.6. Let's look at another one. Square root. This will be 0.1. This will be 0.2. 5 minus 9 squared plus negative 2 minus 1 squared. I want you to keep working it from here. Once you finish, you will do the Houston and Mexico City together. And be sure you go to the description part in this video and click on the link to do your feedback form. And then we'll continue with class.